Alright guys, we're going to look at applications of systems. This will be your notes for your classwork tomorrow. I'm going to show you how to find the area of a triangle first. That's what I'm going to do to start with the notes, and then I'm going to give you an application, and then we can look more on tomorrow in class. I am writing in light blue because my favorite college team is University of North Carolina. I am a North Carolina Tar Heel fan, and so that's why I'm writing in the light blue here for these notes. So let's start off with the area of triangles, and this would be if you're given the three vertices of the triangle. This is how you find the area. So we know the area is typically 1/2 base times the height. So here we still have the 1/2 to find the area, but when we're using matrices, we're going to do 1/2, and then we do the absolute value of the determinant of our matrix. Now, where does our matrix come from? Well, that's going to come from the three vertices that we're going to be looking at. So here's an example. Find the area of a triangle with these three vertices. So if I were to graph these 3 points and then connect them, they would form a triangle. So what I'm going to do is I'm going to form a matrix using these three vertices here. Now, when I do that, the last column of the matrix will always be ones. So we've got a 1, a 1, a 1. That's what always goes there. But the first two columns, and this will be a 3 by 3, the first two columns will be the coordinates of my vertices. So this coordinate goes there in row 1, 7, 2 goes in row 2, and 8, 5 goes in row 3. So now I've got my matrix, which we're calling matrix A here for our formula. Okay. Alright, so what I'm going to do now is I'm going to find the determinant of this, and then I'm going to take the absolute value of it and multiply that by 1/2. And to find the determinant of this, you can use your calculator if you want to, or you can use the diagonal method. I'm just going to use the calculator here to make it a little faster. So we have a 3 by 3, 1, 1, 1, 7, 2, 1, 8, 5. Oops, let me go back here. 8, 5, 1. Got a little ahead of myself there. So let me double check. 1, 1, 1, 7, 2, 1, 8, 5, 1. All right, I'm going to quit, and I'm going to go matrix math determinant, and that's going to be of matrix A, and my determinant is 17. So what I'm going to do now, in order to solve the problem, I'm going to take my area. It's going to equal 1/2 times the determinant of the matrix that I just put in. So the determinant, we just said absolute value of that was, or my determinant was 17. Absolute value of that is 17. So 1/2 of 17, and that's going to come out to be 8.5. And so we're talking about area, that would just be square units. All right, and that's the answer that that we get here. Okay, for area given the vertices. And it's this column right here, the last column will always be ones, and then these first two columns here, those are your coordinates of your vertices. Okay. All right, now let's take a look at an application for systems of equations. And we solve systems of equations today. So all I'm going to do is I'm going to set this problem up, and then you can solve it using the calculator like we did today in class. So Megan and Emma are selling tickets for an orchestra concert. They sell a total of 42 tickets. Adult tickets cost $4. Child tickets cost $2. If they sold a total of $144 in tickets, how many adult and child tickets did they sell? So one thing that I always like to do here is go ahead and define my variables. So I'm just going to say X is adult tickets and Y is my child tickets. Okay. So I like to just kind of go through the problem and break it down sentence by sentence. All right. So it says they sell a total of 42 tickets. So I know that the adult and child, that total is 42. So that is an equation for me. X plus Y has to total 42. Adult tickets, child tickets has to equal 42. It also says in the next sentence that the adult ticket is $4 and a child ticket is $2, and I sold a total of $144. So I'm going to take 4x, because that's my adult tickets, plus 2y, that's my child tickets, and I know that the total money I got from that was 144. Alright, now from here I would just simply solve my system of equations like we did in class today. You would set up your matrix A, which is your coefficient matrix, and then our variable matrix here would just be x and y, and then our constant matrix would be the 42 and the 144. Alright, and I'll go ahead and solve this out. If you have a calculator at home, obviously you can solve this out. If you don't, you can solve this when you get to class tomorrow. But let's put in matrix A, so 1, 1, 4, 2, and then let's put in matrix B, which is 42 and 144. And then remember, when we solve, we go matrix A inverse times matrix B. And that tells me that I sold 30 adult tickets and 12 child tickets. So we end up with x is 30, y is 12. So 30 adult tickets were sold and 12 child tickets were sold to the orchestra concert. And really, we're only going to do 2x2s with these, you know, for the solving. We may throw a 3x3 in there, but for the most part, we're going to do 2x2s. So that gets you going for what we're going to be doing in class tomorrow.